How did our planet, Earth, come into existence? The story of our world begins over 4.5 billion years ago, in the chaotic birth of the solar system. Join us as we explore the incredible journey of Earth's formation from dust to the life-supporting planet we call home today. To understand how Earth formed, we must first journey to the birth of the solar system. About 4.6 billion years ago, a vast cloud of gas and dust, called a solar nebula, began to collapse under its own gravity. As the cloud contracted, it spun faster and flattened into a disk. At the center of this disk, the sun ignited. Meanwhile, within the rest of the disk, tiny particles of dust began colliding, sticking together to form larger and larger bodies. These were the building blocks of planets. These small rocky bodies, known as planetesimals, were the precursors to planets. Through a process called accretion, planetesimals collided and merged, growing into protoplanets. In this violent cosmic dance, our young Earth began to take shape. Early Earth was a molten ball of rock, constantly bombarded by debris. These collisions generated immense heat, keeping the surface in a molten state for millions of years. One of the most defining events in Earth's formation was the giant impact. Around 4.5 billion years ago, a Mars-sized object named Theia is believed to have collided with Earth. The impact was catastrophic. Debris from the collision was thrown into space, and over time, this material came together to form the Moon. The Earth-Moon system we see today is a direct result of this massive event. After the Moon-forming impact, Earth slowly began to cool. During this cooling period, the process of differentiation occurred. Heavy elements like iron and nickel sank to the center, forming Earth's core, while lighter materials rose to form the mantle and crust. This is how Earth's distinct layers core, mantle, and crust came to be. The core remains extremely hot, powering the magnetic field that shields life on Earth today. Earth's surface continued to cool, and volcanic activity released gases from deep within the planet. These gases formed Earth's early atmosphere, which was rich in carbon dioxide, water vapor, and other volatile compounds. As the planet cooled further, water vapor condensed into liquid form, giving rise to Earth's first oceans. These oceans would play a crucial role in the development of life billions of years later. Over the course of hundreds of millions of years, Earth transformed from a molten, hostile world into a stable planet with a solid crust, vast oceans, and an atmosphere capable of supporting life. The molten outer core of the Earth generates a magnetic field, which protects the planet from harmful solar radiation. This magnetic shield was essential for preserving Earth's atmosphere and water, allowing life to thrive. One of the key features of Earth's dynamic geology is plate tectonics. The planet's crust is divided into large plates that float on the semi-fluid mantle beneath. Over time, these plates shift, collide, and reshape the surface. This constant movement has shaped Earth's continents, created mountain ranges, and caused volcanic eruptions. Plate tectonics plays a vital role in recycling materials, regulating the climate, and sustaining life. From a chaotic cloud of gas and dust to the vibrant, life-filled planet we know today, Earth's formation is a testament to the power of natural forces over billions of years. Though Earth's formation took place billions of years ago, our planet continues to evolve. Who knows what the future holds for this blue marble in the vastness of space? Subscribe for more cosmic explorations.